Welcome friends to this new lecture of soil science and technology, and today we will be starting a new topic, that is soil tillage and soil density, and then we will go ahead with other topics. So, in this today's topic we will start with first soil tillage, then we will discuss about different types of tillages, and what are the what is conventional tillage, what is conservation tillage, what are the benefits of conservation tillage, and soil crusting and so on and so forth. So, let us start today's topic, that is soil tillage and soil density. So, let us start with first soil tillage. So, what you actually you know what we actually mean by tillage? The term tillage is basically is the preparation of soil for planting and the cultivation of soil after the planting. So, you can see in this picture that this is tractor is tilling the soil, and there are different types of tillages which we will learn in a couple of minutes. And so, tillage is basically the preparation of soil for planting, and it is basically helps in providing a favorable soil physical condition for growth and germination of the plant. So, let us see what is soil tilth. Tilth is basically the physical condition which occurs after the tillage. So, in other words, tilth refers to the physical condition of the soil in relation to the plant growth. Now, it basically the tilth of a good tilth of a soil basically depends on aggregate formation, and then its stability, then bug density, then soil moisture content, and degree of aeration, rate of water infiltration, drainage, and capillary water capacity, and all these things. So, tillage is a term which shows basically the preparation of soil to provide a favorable physical condition for plant growth and germination and plant growth, whereas tilth is the physical condition which achieved due to tillage. So, let us see what is the first kind of tillage. Now, first kind of tillage is basically conventional tillage, which we generally see uh, in Indian fields. And basically, in conventional tillage, farmers use machines like plow and disc to turn over and loosen the soil after harvest. And this can leave the soil exposed to rain and wind, and which can sometimes lead to erosion of the topsoil that is needed to grow it, needed for the growth of the crop. Now, generally in case of conventional tillage, we generally use different types of implements or different types of equipments for making the soil more loose, and or in other words to increase or to decrease the bulk density of the soil, so that the favorable physical condition for the growth of the crop is maintained. There is more aeration and more air movement and water movement. So, these are the reason generally farmers go for conventional tillage. However, the conventional tillage has a limitation that it exposes the soil which is subjected to different types of wind and water erosion. So, what are the different types of conventional tillage? Now, the first type of conventional tillage is called primary tillage, and primary tillage is the first soil tillage after the last harvest, and it is normally conducted when the soil is wet enough to allow plowing and strong enough to give reasonable level of traction. Remember that this primary tillage is basically done after the last harvest, and it is normally conducted when the soil is wet enough to allow plowing and strong enough to give reasonable level of traction. And this can be immediately this can this primary tillage can occur immediately after the crop harvest or at the beginning of the next crop season. And when there is a sufficient power available, some soil types are plowed in dry condition also. As you can see here, I have given two pictures where the farmers are tilling the soil, and this is an example of primary tillage. Remember that primary tillage always done after the harvest of the previous crop or just beginning of the beginning of the next wet season. So, what are the objectives of primary tillage? The primary tillage objectives are, there are four major objectives. First of all, to attain a reasonable depth, that is 10 to 15 centimeter, we call it furrow slice of soft soil with varying clod sizes. Now, reasonable depth, to attain a reasonable, for the germination of a crop and for their proper growth, we need to maintain a good soil favorable condition or good soil physical condition up to 0 to 15 centimeter depth, because that is the depth up to which most of the plants roots for most of the field crops grow. So, the first objective is to attain a reasonable depth of soft soil with varying clod size. The second and one of the major objective of primary tillage is to kill the weeds by burying or cutting and exposing the roots. Third one is the soil aeration and water accumulation, and finally to chop and incorporate crop residues. So, these are couple of these are couple of objectives for primary tillage. And there is another type of tillage called secondary tillage. Remember that secondary tillage is any working completed after primary tillage, and there are a couple of objectives for doing the secondary tillage. There are 5 objectives for doing the secondary tillage. One is, as you can see here, one is reduction of clod size, then weed control, then incorporation of the fertilizer, then paddling and leveling of soil surface. Now, we know that in the primary tillage we reduce the, we break down the clods, and further in the secondary tillage we try to reduce the clod size. The secondary tillage also helps in weed control. Secondary tillage helps in incorporation of fertilizer. We will discuss that later when we will discuss the fertilizers. Puddling is an important secondary tillage operation for rice crop, and also leveling the soil surface, because when we are reducing the clod size, it is becoming more smooth. So, you can see in this picture that this is an example of secondary tillage. Now, regarding paddling, you must have seen this paddling quite a lot time in the rice field, because we generally do the puddling operation in the rice field in the standing water, in the presence of standing water, and we are further breaking down the clods due to secondary tillage. And one of the major reason of doing the puddling is to make an impervious soil layer, and due to the impervious soil layer, the water movement or water infiltration into the soil is nullified. So, as a result, the water gets accumulated at the top of the soil, which is required for the growth of the rice crop. So, this is called puddling, and this is an example of secondary tillage operation. So, you have seen that there are different types of primary tillage, and there are some limitations of primary tillage, because of primary tillage soil become more subjected to erosions, and so in recent decades agricultural land management system has been developed that minimizes the need for soil tillage and leaves the soil surface largely covered by plant residues, and thereby maintaining several aspects. So, we call this new technique of soil tillage as conservation tillage. Now, as a result of conservation tillage, generally we maintain soil biological habitat, and we stabilize the soil structure. We maintain first soil biological habitat, then we stabilize the soil structure, then we can conserve the soil organic matter, and finally physically protecting the soil from drying sun, scoring wind and beating rain. Now, as this conventional tillage requires minimum soil disturbance, obviously the soil macroorganisms and microorganisms can thrive better in the soil, and stabilizing the soil structure because we are leaving the plant residues, not removing the plant residues. These decomposed and produces huge amount of organic matter, and as you know from our soil structure lecture that these organic matter are helpful for producing the better soil structure. And conserving soil organic matter, obviously we are not exposing the soils, and since we are not exposing the soil, it is not coming into direct contact with the sunlight, and as a result there will be no there will be reduced decomposition of organic matter, and ultimately there will be conservation of organic matter. And finally, physically protecting the soil from drying sun, scoring wind and beating rain. Obviously these are couple of limitations of primary tillage which can be addressed through second conventional tillage. Now according to the US Department of Agriculture or USDA, they define conservation tillage as that tillage practice that leaves at least 30% of the soil surface covered by residues. So this is an important aspect. So unless you unless you leave the plant residues into the field after the harvest, you cannot term it as a as a conservation tillage. So it is an important aspect of conservation tillage. You have to maintain at least 30% of the soil surface covered by residues, so that you can conserve both organic matter, you can produce the stabilized soil structure, and you can produce the better habitat for soil biological organisms. So, now conservation tillage is basically a technique for planting seed that minimizes the disruption of the soil and therefore helps prevent soil erosion. We have already discussed that in the last slide. And remember that farmers use special equipments to plant seeds, leaving most of the residues like stalks of the previous crop intact, and planting in this way allows the crop residue to break down, which adds further organic matter like composting while protecting the soil from erosion. We have already covered that in the last slide. So basically while we are leaving the residues into the field, they decompose and further adds organic matter into the soil and also protect the soil structure and protect the soil from being eroded. So these are some advantages of soil conservation tillage. Another important tillage operation for conservation tillage is called no-till, and basically in case of no-till, one crop is planted in the residue of another with virtually no tillage. So this is called no-till condition. As you can see in this picture, they are just planting the seeds in the residue of another, so it is virtually no tillage is being done. It is called no-till condition. Another important unfavorable condition for soil is called soil crusting. Now, soil crusting generally occurs due to due to the beating action of falling raindrops. Now, you know that falling drops of water during heavy rain or sprinkler irrigation can beat apart aggregates exposed into the soil surface. So, if we think this is a soil particle due to the beating action of falling rainfall, these aggregates will further breaks down and it will produce the individual particles, and these once the aggregates become dispersed, these small particles and dispersed clay tends to wash into and clog the pore space. Once it clogs the soil pores, the soil surface is covered with a thin and partially cemented low permeability layer material called a surface seal. Now, when the surface seal dries, it forms a hard crust. So, that is called soil crusting. You can see the soil, the figure, the picture of soil crusting I have presented here, and you must have seen it a couple of times. So, this is an example of soil crusting, and these soil crusts are basically occurred from clogging the pores, soil pores by very small particles like clay particles, and thereby restricting the movement of or the restricting the infiltration of the water into the soil. So, this is an example, this is called the soil crusting. So, what are the problems of soil crusting? Why should we bother if there is a soil crusting? Obviously, because if there is a soil crusting, it will inhibit soil water infiltration, it will increase the erosion losses, and it will inhibit the emergence of the seedlings, because due to the soil crust and the hard surface, the seedling cannot germinate. And in especially in arid and semi-arid regions, soil sealing and crusting can have disastrous consequences, because high runoff losses leave little water available to support the plant growth. So these are some problems which occur due to the soil crusting. Now you can see there are three pictures of soil crusting. As you obviously can see that crust layer, and finally you can see the last picture, that the seedling is struggling to break a soil crust. So this is a problem for soil germination. So obviously we should be very careful to avoid any type of soil crusting, or if it occurs, we must break the soil crust due to using different types of management practices. So, what are the different managements management of soil crusting? So, for example, first, keeping some vegetative or mulch cover on the land to reduce the impact of raindrops. So, if you keep some vegetative or mulch is a protective layer which over the soil surface. So, if you can produce a protective layer over the soil surface, obviously it will reduce the impact of the beating raindrops, and once a crust has formed, it may be necessary to rescue a newly planted crop by breaking up the crust with light tillage. And for light tillage, you can use a rotary hoe, as you can see in this picture. As this is an example, this is a rotary hoe, and this rotary hoe breaks the soil crust, and preferably when the soil is still moist. And obviously all the soil casting can also be minimized using different types of soil conditions. So what is soil conditioners? Soil conditioners are basically some chemical agents which which we generally add to the soil to improve its physical condition. So improve management of soil organic matter and use of certain soil amendments can condition the soil and help prevent clay dispersion and crust formation. Two important soil conditioners are gypsum and organic polymers. So why gypsum? And gypsum is basically used for collecting the soil physical condition, collecting the soil physical condition, and used in low salinity to sodium rich soil, and finally it improves the flocculation of the soil. What do you mean by flocculation? So if there are individual soil particles or individual clay particles, by adding the gypsum, we are basically adding calcium sulphate to H2O, and this calcium sulphate will generate calcium cations. These calcium cation will help in aggregation of these individual soil particles together to form an aggregate, and ultimately it will settle down. So this is called flocculation condition. This is called flocculation. And flocculation occurs due to aggregate formation, and this calcium which comes from gypsum basically helps in the flocculation condition. And remember that when there is a flocculation, obviously the structures are stabilized and the porosity, favorable pores will be favorable condition will be maintained, porosity will be maintained for proper movement of air and water for the growth of the crop. So these are important aspects. Another type of organic conditioners are polyacrylamide or PAM, which is basically effective in stabilized surface aggregates when applied as rates as low as 1 to 15 milligram per liter of irrigation water, or sprayed on at rates as low as 1 to 4 kg per hectare. So when we apply these organic conditioner, these also helps in producing better stabilized soil structure, and as a result of stabilized soil structure, obviously the porosity will be maintained, and as a result better air movement and water movement will be ensured. So, these are some soil conditioners. So, let us see. So, we have covered the soil tillage part, different types of tillages, and then conventional tillage, conservation tillage, primary tillage, secondary tillage, their objectives, their problems, and we also covered the soil crusting. So, let us start another important aspect, that is soil density. Now, there are two types of density we generally talk when we are talking about soil. The first one is called particle density, and the second one is called the bulk density. Okay. So, let us start with the particle density. So, particle density, or generally we term it as DEP, is defined as the mass per unit volume of soil solid. So, if a 1 cubic meter of soil solid is weighed 2.6 megagrams or 2.6 tons, the particle density is 2.6 megagram per cubic meter, which can also be expressed at 2.6 gram per cubic centimeter. Generally, we express this soil density in gram per cc. So, 2.6 megagrams or 2.6 tons per cubic meter is equivalent to 2.6 gram per cc. So, particle density, remember that it is essentially the same as the specific gravity of a solid substances, and particle densities for most mineral soil vary between the narrow limits of 2.60 to 2.75 megagram per cubic meter, or generally for sake of simplicity we generally consider an average value of 2.65 gram per cc as the soil particle density. So, another important density is bulk density, and we generally term soil bulk density as dB, which is defined as the mass of a unit volume of a dry soil, and this volume includes both solids and pores. As you know that soil contains both solids and pores. So, when we are talking about bulk density, we are measuring, we are considering the volume of both solids and pore. So, this is the difference between the bulk density and particle density. In case of particle density, we are only considering the volume of solid particles. However, in case of bulk density, we are considering the bulk volume, that is the volume of solid plus volume of pores. So, the units are same as particle density, generally expressed in terms of gram per cc, but the value of bulk density is changeable like particle density, and the generally coding instrument are used to determine the soil bulk density. So, let us see how we generally measure soil bulk density. Now, another important thing I just mentioned, that value of bulk density can be changed. However, particle density is more or less constant. So, we will see some example later on. So, how we determine soil bulk density? Generally, we use some cylindrical core for determining the soil bulk density, and as you can see, this is a cylindrical core. I have shown here some pictures. This is a cylindrical core, and which has got a fixed volume. So, the sampler head contains an inner cylinder. This is the inner cylinder, and which is basically driven into the soil, blows from the top of the hammer. So, we generally give blows from the top with the help of a hammer, and the inner core contains an undisturbed soil core. So, the inner core contains an undisturbed soil cores, and generally we trimmed on the edge of the knife. So, after we take out the soil, we generally trim the edge of the soil, and the volume can be calculated from the length of the diameter. So, we know its length, we know its diameter. So, from that we can easily calculate its volume, and obviously the weight of the soil can be calculated after drying it at 105 degrees centigrade for 24 hours. So, this is how we calculate the soil bulk density. So, calculation formula of soil bulk density I have discussed in the next slide. So, let us see. So, let us first consider particle density. So, if you consider 4 blocks of solid rocks where there is no pore space, obviously the total volume will be 4 multiplied by 2 centimeter into 1 centimeter 1 centimeter. So, the total volume should be 8 cubic centimeter. However, the weight, the cumulative weight for all the 4 blocks is 21.6 gram. So, particle density is basically the total weight by the volume of solid. So, it gives us 2.7 gram per cubic centimeter. So, this is a particle density. Obviously, it is a prismatic solid mass consists of 4 tightly fitted mineral blocks where there is no pore space. It is important. Now, in case of bulk density, consider the same 4 blocks of solid rock arranged loosely to form a cylinder of soil. So, you can see this is a cylinder of soil, and in this cylinder of a soil all these 4 blocks are arranged together so that it includes the space between the mineral blocks also. So, you can see these are the space between the mineral blocks. So, the total volume of the cylindrical soil is basically pi r square inch. So, you can calculate is ultimately 17.7 cubic centimeter, and weight is same, obviously 21.6 gram, because pore space does not contain any weight. Obviously, bulk density is 1.22 gram per cc. So, you can see this cylindrical pore, there are 45% solid and 55% of pore space, and as we know this 2.5 centimeter their length and 3 centimeter diameter, as we can see from the last slide, we know that cylindrical core length and diameter. So, we can easily calculate this. So, once we calculate this, we just have to calculate the weight of the soil, and from there we can calculate the bulk density. Obviously, in this case it is a dry bulk density because we are drying the soil, we are taking the weight of a dry soil. So, here also you can see in the field 1 cubic meter of a certain soil appear as 1.33 megagram or tons solids and pore space. So, in the field 1 cubic meter of certain soil appeared as 1.33 megagram. So, to calculate the bulk density of the soil, you see volume is basically 1 cubic meter, which contains both solid and pores, because this contains some pores also. Weight is 1.33 megagrams. Bulk density, weight of oven dry soil, and volume of soil, that is contains solid plus pores. So, therefore, bulk density we are getting 1.33 by 1, that is 1.33 megagram per cubic meter. So, if all the solids could be compressed to the bottom, the cube would look like this. So, you can see we are compressing the soil, we are half of the pore space and half of the solids. So, solid will still contain still weigh 1.33 megagrams, and to calculate the soil particle density we are getting volume right now 0.5 cubic meter, weight is the same, weight is same 1.33 megagrams. So, soil particle density is volume, weight of soil, weight of solids and volume of the solids. So, we are getting 2.66 megagram per meter cube or 2.66 gram per cc. So, I hope that now it is clear how we calculate soil particle density and soil bulk density, and these are very much important soil physical parameters or physical properties, which has different connotation with soil physiochemical conditions and favorable soil physiochemical conditions. So, let us wrap up here, and in the next lecture we will start from the next slide. Thank you very much.